Hello, I'm the molescent Mr. Daycock, and today I'm going to be teaching you about integrating using the functions we've discussed previously in terms of differentiation, but in fact just going the other way. If you're not sure about those different functions in terms of differentiation, you might want to go watch my previous videos on trigonometric functions for differentiation and other functions in terms of differentiation, because that's going to be very important here. So first of all, we've got an antiderivative here. We've got dy by dx is equal to cosec squared of x minus 7 over x minus 1 over 2x squared. So what we need to do is consider each one in turn. So cosec squared of x, well, this is a derivative, so we're trying to reverse it. So we need to ask ourselves, what would differentiate to cosec squared of x? And the answer is cot of x. I've written cosine there. Cot of x, and that differentiates to minus cosec squared of x. So what we want is minus cot of x will be the thing that differentiates to positive cosec of x. And therefore the antiderivative of the cosec is going to be, we're going to start off with y equals minus cot of x. Secondly, we've got this negative 7 over x. And we have to ask ourselves what differentiates to 7 over x. And the answer is the natural log of x. But there is a problem here. And the problem is that our graph of negative 7 over x is going to look like this. And it is valid everywhere. And this is always true, whatever natural log you're dealing with, whatever reciprocal you're dealing with, it is valid everywhere except at 0. Whereas the natural log is only valid for positive. So this is everywhere except 0. This is only x positive. So how do we deal with that? Well, we remember that if I were to differentiate the natural log of 3x, we're just going to get 1 over x still. The 3's actually cancel out. And therefore the same applies to the natural log of negative x. That still differentiates to just 1 over x. And so to eliminate this problem, to get it on both sides at once, and of course this is only valid, this one we've just talked about is only valid for x less than 0, because it needs to cancel out. So to get what we want, we add modulus lines. So in fact, what we want, and of course that's really just for 1 over x. So to get that negative 7 in, we're going to multiply it by negative 7. And so what we get is negative 7 multiplied by the natural log of x. But remember, to get those negatives as well, we want this modulus sign added in. And then lastly, this last bit here, we don't even need to worry about that too much. This is just our standard. We've got negative 1/2 of x to the minus 2. And so this is just the power rule. We add 1 to the power, divide by the new power, so we get x to the minus 1. Divide by that new power, and we get positive 1/2. And so we get plus 1 over 2x. And that is the entire thing, except for one thing, and hopefully some of you are screaming at me right now, plus c. And if you're not screaming that, you should have been. Let's move that there to make it look a bit neater. And this here is our answer to this question, just by asking ourselves what would differentiate to these things, and therefore we can reverse it and find out what these things integrate to. And so if dy by dx is cosec squared of x minus 7 over x minus 1 over 2x squared, our answer is y equals negative cot of x minus 7 natural log of the modulus of x plus 1 over 2x plus c. Okay, next part. Find the integral of e to the 3x plus 4 sine of 7x. Exactly the same way, and of course dx on the end, exactly the same way we're going to ask ourselves what would have differentiated to e to the 3x plus 4. Well, it's exponential, so I'm just going to consider e to the 3x plus 4. But this is a chain rule situation. I've got to write that as u equals 3x plus 4, and y, as it were, is equal to e to the u. So dy by du is still e to the u, but du by dx is equal to 3. And so our answer to this, the dy by dx, is going to be equal to 3 times by e to the 3x plus 4 by the chain rule. So this would give us a 3 there. So we don't want a 3 there. So to solve that, I just have to multiply everything by a third. Or, if you can think of it in terms like this, similar terms, this 3 just comes out as a division. So we're going to end up with 1/3 of e to the 3x plus 4 for our first part. Second part, 4 sine of 7x, exactly the same thing. 4 sine, let's give myself some more space over here. Let's do 4 sine of 7x. What might differentiate to that? Well, cosine differentiates to minus sine, and so I'm going to suspect it's minus cosine of 7x. But of course, if I differentiate like that, the 7 is going to come out, and therefore going backwards I'm going to need to divide by that 7, and so I get 4/7. Because if going forwards I multiply by the 7, going backwards I have to divide by the 7, and so I'm going to get minus, because it's minus cosine, remembering our coefficient, which is 4/7 cosine of 7x. And then of course plus c. And hopefully we all remembered that before I mentioned it. Okay, last example. Calculate the integral from 0 to pi over 4 of sec x tan x dx. Now this one looks like it could be horrible, but actually there's a really nice way. You must need to remember that if you have sec of x, that differentiates to sec x tan x, and we're good. So the integral of this, of sec x tan x dx, is going to be equal to just sec x, but with the limits applied, 0 to pi over 4, and that is going to be equal to sec of pi over 4 minus sec of 0. Now we need to remember what secant is. Secant is 1 over cosine, so this is equal to 1 over cosine of pi over 4 minus 1 over cosine of 0. Cosine of 0 is 1, so this is equal to, that's minus 1 over 1. Cosine of pi over 4, that is 1 over root 2. And this gives us, simplifying these fractions, we get root 2 minus 1. And that is our exact answer to this integral here. Okay, so that's just a quick video on how to integrate various different functions based upon their derivatives. So just sort of anti-differentiating all of these different things. Again, if you have any questions about this, ask them in the comments, or just go back to the video and check that key point again. Thank you very much for watching, and I'll see you in the next video.